Lesson 6.5, we're going to use the proportionality theorems. We use proportions with a triangle or with parallel lines. So looking at the first theorem is called the triangle proportionality theorem. And criteria for this is that we must have a parallel line to the third side or to one of the sides. Then what happens is it divides the two sides proportionally. So if TU, segment TU, is parallel to side QS, then RT over TQ will equal RU over US. The converse of this states that if I have that proportionality, then that segment is parallel to the third side. So if I have RT over TQ equal to RU over US, then I can say that TU must be parallel to QS. So let's use this to find lengths of segments. So I can see that I have parallel. So I have this parallel to the third side. So I know that it divides it proportionally. So AB over 5 equals 12 over 6. So AB equals 10. Once again, I can see parallel. So it divides proportionally. Oops. I think this is 15, so AB equals 15. Okay, and you can divide or reduce those ratios if you want. I'm going to work with smaller numbers if they're reduced. Just keep in mind, oh no, that'll work, never mind. Okay, in order to determine if I have parallel, I need to see if I have the same ratio. So does 6 over 3 equal 8 over 4? 6 over 3 is 2 over 1. 8 over 4 is 2 over 1. So yes, BD is parallel to AE. Let me do the same thing here. 2 over 1, 3 over 1.2. Getting rid of decimals. So they're not equal, so no. We can use this same kind of proportionality relationship with just parallel lines. So if I have 3 parallel lines and they're cut by 2 transversals, then those transversals are divided proportionally. So UW over WY will equal VX over XZ. So we're going to look at this figure and we're going to complete the proportions. So you just have to make sure, and since those transversals intersect, you can think of these as different triangles. So you can think of this as a triangle there, just so you know, as a triangle here, and as that triangle. So just keep that in mind, that that can also exist. So GC over CF, GD over DB. AF, FC, so it's going to be EB over BD. CD, see that's one of those parallel segments, over FB, GD, so that's the side, and this is going to be GB. So that's kind of like the base of the triangle is CD, the other base, the purple one, is FB, GD red, and underneath there, over purple. AE, again, is a base, the blue base. CD is the red base. GE is the blue side, so I need the red side, which is GD. FG is purple, over AG, blue. FB, which is purple, over AE. GD red over GE blue. What over AE, which is blue, so I need red, which is CD. If a ray bisects an angle of a triangle, then it divides the opposite side to segments whose lengths are proportional to the side lengths of the other two sides. So the proportion AD over DB is going to equal the sides CA over CB. So again, the split at the bottom, if I did left to right, will equal left to right. And I'm sure we don't really have to solve this. So same thing here. If I did 8 over x is equal 12 over 9. Now in this case, you have to represent this segment here. Since you know the whole length and x is the other piece, that the shaded region is 20 minus x. So you have 20 minus x over x equals 11 over 14. Solving x equals 11.2. It's a decimal. Okay, and then find the values of the variable. So we have to kind of see what we have here. We're looking for x. So I can do the split of the parallel lines, so I can do 4 over x equals 6 over 3. Okay. And then looking for M. M is the base of a triangle. It's the base of this triangle. And then we can use also this green triangle. So I have to add those two together. 4 plus 2 is 6. Over M. Then I'm going to add that other 2 to have the green side is 8 over 5. So equals 3.75. And to find A, I can do red and purple. So I'm going to do the 2 over A. That's an A. 6 over, we just found, or I'm going to do the green. Sorry, that'll make it a lot easier. So I already know that's 8 over 5. Let's make sure that looks like an A. So we have 8A. Okay, and this ends this lesson.